Presenter is Marianela, Ciolfi, Felice.
Yes, thank you. So today I'm going to present Beyond Snapping, Persistent Tweakable Alignment and Distribution with StickyLines. Okay. This is the project we did with Nolwenn, Maudet, Wendy, Mackay, and Michel Beaudouin-Lafon. So, have you ever wasted time aligning graphical objects? When people create graphical documents, such as slides or posters, they need to position graphical objects precisely. And existing tools usually provide commands to align and distribute objects, a set of selected objects, either horizontally or vertically. So for example, let's say that I want to align these three elements by their tops. So I do it, now these other three by their bottoms, and this is what happened, and we're back to the beginning. So we wonder if current tools really address the complex aspects of alignment and distribution, or if users still struggle and waste time when they are editing layouts. So we conducted an observational study with 12 regular users of graphical editors, being 6 of them professional designers. We asked the participants to show us recent projects in which they had to lay out graphical objects. And we focused both on specific problems they had and also on the things that worked well. We also encouraged them to show us the tasks that were problematic for them. As a result, we found that most current systems lack first, persistence. The alignment commands leave no trace of their use. The system forgets that two objects were related as soon as the command is applied, and this leads to repetition of actions, as I showed in the previous clip. Second, the systems also lack control, or what we call control. So the effect of the commands can be really hard to predict for users. The algorithms are never revealed to the user, and it's the system who controls how they get applied. Third, the systems lack generality. They are usually restricted to horizontal and vertical alignment and to the even distribution of objects. And there are no commands to, for example, align objects into a circular shape or around the outline of existing objects. So since the original work on snap-dragging by Beer and Stone, many techniques have been proposed that to solve graphical alignment that went beyond snapping. For example, Masui's hypersnapping reveals alignment relationships through anchors at the snapping points. And then Raisamon's alignment stick used a physical ruler metaphor to push objects with it, and this was one of the first attempts to turn alignment into a persistent object that the users could directly manipulate. But the most relevant work for us is magnetic guidelines by Beaudouin-Lafon and Mackay. And a magnetic guideline, which is the green lines that we barely see there, they reify alignment into persistent objects that the users can manipulate. So elements can be attached to a guideline, and when moving the guideline, the objects move with it, and they stay aligned. So to tackle the 3 problems that I mentioned, lack of persistence, control, and generality, we designed StickyLines that build directly on magnetic guideline and extend it. So StickyLines was designed to support persistency, as we will see now. For example, to achieve horizontal alignment, we can create a straight horizontal guideline, attach objects via snapping, and then when we drag the guideline, the objects are kept aligned. Now alignment is truly persistent. Objects can also be added to more than one guideline at a time. As we will see now with the pink rectangle, when moving the guidelines, the object is still aligned to both of them. And when conflicts occur, the guideline that is being dragged takes the priority over the object, as we can see there. But I can click on a relationship that is shown in orange, and now it's prioritized. So the alignment will never be broken. We can also align one guideline for all its objects, this is highlighted in orange, or make it exclusive, so all the objects will ignore the existence of other guidelines. Only one guideline can be prioritized at a time for a certain type of snapping point. So for example, if I now prioritize the right side of the blue rectangle, the previous one will be overwritten. The system can also detect potential alignments and display them as dotted lines. If the user releases the mouse while this line is visible, then a sticky line is created. This, combined with the fact that the user can simply move guidelines to edit the layout, gives not only persistence, but also more control to the user over the layout. Other cool stuff we can do is aligning objects with only one action, if they are roughly aligned already, or collecting objects as we pass by releasing the guideline close to them. We also included distribution capabilities accessible through a tool palette in the guideline. When we deattach and reattach objects, it's automatically recomputed. We can also distribute the other reference points like center, left, or right. And these reference points used by the system are revealed as red marks when we point to the line. Also, sticky lines support control. Let's say that I want to create a play icon. So I would align these two elements, right? So the system will use the mathematical center, and from its perspective, these are two perfectly aligned. But from the human perspective, the visual weight is on the triangle on the left, right? So the user needs to handle this manually. So for example, the user could hit the right arrow many times until it looks okay. But current systems completely ignore this user's activity of making small adjustments to alignment that we call tweaking. But what happens if we capture this? Because we can. If we capture the trace of the arrow key, now the action of tweaking alignment becomes an object in its own right, the violet thing that you see there. So now there is an object, the system can record it, and we don't need to do it again. And we can also, for example, copy it, as we will see now, and paste it into other objects. And they are all saved by the system. The object remembers all its tweaks, so they can be reused in other guidelines, or they can be deleted if we don't need them anymore. On the other hand, objects usually have bounding boxes that represent their borders and how much space they occupy. But we can let the user modify these borders to match the perceived borders. So for example, in this particular case, we can do that, and we can, now that is an object, we can copy it, and we can reposition it into another object. If we edit a bounding box while the object is on a distributed guideline, the system will recompute the results on the fly so the user can play with the results very easily. Finally, sticky lines also support generality, going beyond horizontal and vertical alignment, as we will see in these examples. What happens if the user has these elements aligned in a straight guideline, but they want to have them in a circular shape? So they could simply take it and reshape it into a circle and resize this circle. We could also use the properties of existing objects in the layout, for example, their contour, their outline. So we can call these guidelines that we call ghosts, and they take the shape of the object they surround. The gap between the guideline and the object can be controlled by the user through direct manipulation. This is yet another type of guideline that can keep objects parallel at any angle, so we can move it, and the objects are still parallel. We can also expose a curve that represents how the objects are positioned along the guideline. So we map the order of the objects to their position in the guideline. We will see that now again in a second. So for example, in traditional commands, this mapping is linear, right? But we can let the user modify the curve by direct manipulation, and for example, cluster them at the left side and make them more space at the right side, or the opposite. So we wanted to see if sticky lines are more efficient than commands for complex alignment. So we ran a controlled experiment with 12 participants using a 2x2 within participant design to compare sticky lines to traditional command tools. But since many of the features in sticky lines are not available in traditional tools, we compared only horizontal and vertical alignment and even distribution. So the experiment had two primary factors: technique, that is sticky lines or commands, and difficulty, that is easy or hard. To achieve an optimal solution in terms of numbers of actions, the easy tasks don't require particular order, and they involve either only alignment or distribution. While the hard tasks, they require a certain order and involve both alignment and distribution. So for example, first the distribution in blue, only then the alignment in red. So the difficulty conditions were grouped by technique, and both factors were counterbalanced across participants. Participants performed three trials in each of the 4 conditions for a total of 12 trials. For each trial, they were given a printed layout where they had to reproduce a target. And we told them to create it as quickly and as accurately as possible for them. So our results suggest that sticky lines are 40% faster for hard layouts than commands. The graph here shows the difficulty in the horizontal axis and the mean duration in seconds on the vertical axis. The blue line corresponds to sticky lines and the red line to commands. So we see there is an interaction effect that is not significant for easy tasks, but the harder the task gets, the better the sticky lines are in terms of performance. Our results also suggest that sticky lines use 49% fewer actions for hard layouts than commands. So in this graph, we can see the mean number of, of actions, and we see that the harder the task, the more actions are required to complete a layout with commands. And this can help us to explain why commands take more time than sticky lines. We are also interested in knowing how designers can use and appropriate the more novel features of sticky lines. So we ran a structure observation with 6 designers, and the StickyLines version used most of the features that I showed you, but not all of them, because we wanted to keep the trainings short and avoid overwhelming the users with a lot of features that they had to learn. So the first task was to recreate a poster, this one, that it was printed, and it has complex and ambiguous alignment because we wanted to see if users had different strategies to solve them. This is an example of a participant. The task 2, they had to reuse the same shapes and the same structures to adapt it to a different page orientation, as we see in the video. And then in task 3, they had to produce 2 more variations of this poster using the available shapes. This is also an example from a participant. So as a result, we observed that most of the participants perceived the sticky lines not only as an alignment and distribution feature, but also as a grouping feature or as a way to structure the layout. And they also asked for more ways to interact with the sticky lines. For example, they asked us, why can I not distribute the guidelines or align guidelines themselves? So for example, here the participant is using the small guideline on the left and using tweaking also to keep objects grouped even if they were not visually aligned. And here the participant wanted to merge 2 lines, but it was not possible in our prototype. So as a future work, we would like to add first support for symmetrical structures and also to allow the users to align and distribute the guidelines. So today we saw how sticky lines reify the concept of alignment. The concept of alignment and distribution into interactive objects that are persistent, controllable, and tweakable by the users. Thank you.
So we have a few minutes for questions.
Also, our group is recruiting. In case you're interested, there you have the emails that you can write to.
Questions? All right. Well, guess who has a question then? Me. So what would you say, I know you had the future work slide, so that's, I guess, part of an answer, but what would you say subjectively is the hardest type of task still to perform? Like where's the biggest gap this still leaves? Or is everything pretty much easy at this point?
You mean the things that this doesn't solve or the things that designers need to solve?
The things that this doesn't solve, although perhaps there's overlap in those two.
No, I think that the thing of symmetric shapes, symmetric structures, so for example, some users wanted to have a vertical guideline, then a horizontal one, and have different shapes that had to be mirrored from the middle, and you could do a tweak, and then you could think of doing copying the tweak, but then reverse it. Mm-hmm. This is mirrored to the other shape. This should be very easy to do with the system because of the way it's designed, but it wasn't possible in that. Also, I think that a zoom-in environment would also help very much to overcome the limits, especially with the thresholds in snapping, and if you work with very little objects, that can help a lot.
Did you find that it's still subject to some of the challenges when you try to place things very, very close, the snapping gap? Because I noticed on your related work slide, you didn't, might be in the paper, but you didn't mention the, I think it's snap and drag work from Patrick Bowdish and others.
Yes, it's in the related work.
Yeah.
Yes, that could be combined with that technique.
Right.
Very easily.
Yeah. Those can work together.
Also, the threshold can be adaptive to the size of the object.
Yeah,
That should be very trivial to implement.
Anyone else want in on this conversation? We're having a good time up here, the two of us. There's one in front here. Go ahead.
First off, that is really impressive. I use Illustrator all the time.
That's a very good question. Right now, it's only applied to position, but you could think of having a tool that you can activate or deactivate when you need it. Maybe, for example, in the tool palette of each guideline, that can tell you, okay, activate, I don't know, stretchiness. So you can stretch an object. So you put them both in the same guideline, and the one that needs to be stretched will be stretched if you move one of them. Yes, definitely.
Okay, we have time for one last question. Yeah.
Sorry, I cannot hear you.
I can repeat the question. So how would this work on touch-based interfaces instead of mouse-based?
I think it could be done. Actually, there is one work where magnetic guidelines have been implemented in touch-based interfaces where you drag the lines with your finger. And I think that sticky lines could be also adapted to this thing. Of course, you will have the fat finger problem, but you need to solve that anyways in any technique you do for touch-based, right? I don't know if that solves your question or not.
Okay, thank you.